Okay, these are problems from section 9.1, and try to get through these pretty fast, short and sweet, I hope. Most of it's just the writing down. First of all, we wrote down what we had from problem number 21, and this was the function, and this was the expansion. This is what it ended up being when we worked backwards. Remember, we used the S equals A over 1 minus R to come up with this function for this expression using the common ratio, etc. So this is what's going to carry through for all these problems. So first of all, you want to write it out, and then we're just going to take the derivative of both sides. That's basically what they want you to do. Now, if we take the derivative of this, we can use the derivative of 1 over x is negative 1 over x squared, except we have a chain rule here. So this is the x is going to be 1 minus 2x, so I've got to take the derivative of that, which is negative 2. So keep that in mind. We apply the chain rule, so all we do is take the derivative of both sides. If I take the derivative of this, it's 0. If I take the derivative of that, it's 2. And then that's 8x, then 24x squared. And then when you write your general term, make sure you have your constant separate, because remember, when you take the derivative, the constant stays the same, and then we take the derivative of this using the power rule. That's n times x to the n minus 1. It goes on out, and then we just sum it up. And we can simplify here. The negative times the negative is positive. So this was my left side. This was the derivative of the original function, all right? And this is the expansion of that function. And this ends up looking like this if we just use an index in a summation form. And I would notice the index has got to change. Here it was 0. Here it's going to change to 1. And then it's going to work. Okay? Take a look at that. This was mostly your work right here. Most of the other was these two steps were just writing down and then telling what you're going to do. Okay? That's 27. Here's 28. And again, this is from number 22, so this was the function and this was the expansion. And we just take the derivative, and this is a function inside, so we would have to apply the chain rule, but the derivative of x plus 1 is just 1, so we're okay. So here I'm going to take the derivative of both this left side and the right side. The derivative of the left side is going to be negative 1 over 1 plus u squared du, which is just 1, so we're okay there. We can put the 1 in front, and then I can take the derivative of each of these terms. The derivative of 1 is 1. The derivative of 1 is 0. Then this derivative of this will be negative 1. And then 2 times x plus 1. And then negative 3 times x plus 1 squared, etc. until we get to the general term. And again, this is going to be a constant. This describes the alternating signs we have. When n is 0, that's 1. When n is 1, it's negative. Then positive, then negative. And then, so this stays the same because that's a constant. Then I'm going to use the power rule on this, and that's going to be n times x plus 1 to the n minus 1. And then we just use that in the expansion. We set our index so it will work at n equals 1. So the index is a little different here than here, because it needs to be like that to make the derivative work. And again, this was my, as in problem number 1, I should have restated that this is my interval convergence of the values of x that the original function needed, so this is going to be the same. Okay, that was for our theorems. Take the derivative, the interval convergence is the same. Okay, so that's 28. And here's 29. Let's see if we can get this set up here. Way up here. Okay, here's 29. There you go. And again, for problem number 23, this was my function and its expansion, what it is equal to, and this is the general term. The general term is very important because in a pinch you can just take the derivative of that. And then I wrote it down, so I did the formalization. I did all the little formal steps they do. So I took the derivative of both sides, and if you take the derivative of 1, you get 0. If you take the derivative of this, you get negative, and then this would be like 1/2 x minus 3/2, and the derivative of 3/2 is 0, and the derivative of 1/2 x is just 1/2 of the minus sign. We take the derivative of this, the derivative of this term, watch the signs, and then we take the derivative of the general term. Now this is going to stay the same because that's a constant in front. Well, it's just not a variable, but it's to the nth power, it changes. But this is what we have to worry about. So this is going to be n times x minus 3 to the n minus 1. So this is the coefficient. We don't really need to worry about taking the derivative of that. There's no x involved. Okay, and then this would be my general term. So my index has got to go to 1 to make it work. And that's going to be what you've got. This was the original interval convergence of the original function and its expansion, so that's what we have over here. I just took the derivative of both sides. If I take the derivative of this again is going to be like 2, and then it's going to be the 1 over 1 minus x squared. Except my x now is, or my 1 over u, I could say, is a negative 1 over u squared times du dx. But the du dx is just 1, so we're okay so far. Alright? So the derivative of this would just be that. Okay? And once I take the derivatives of these, I just do see that I have this form here. And this is over this interval convergence. Okay? So that should be pretty straightforward. Okay, and then the last one, number 30. Now this is a little bit trickier because we do have the chain rule involved here. So take a look at this. A little bit higher there. Okay. So this was from number 24, but it was in number 24 we had it written like this, 6 over 3 minus x. So I just reversed them. I put negative x plus 3, and then factored out the negative sign, and then put the negative sign in the front. So we could write the function. We could write this like this, and it's a little nicer like that. When we take the derivative, it's going to make sense. And this was the expansion given by this general form, and this was from problem number 24. So that was the summation form for that, and this was the interval convergence. Okay. Now, we're talking about this function. Now, notice that the derivative of x minus 1 over 2, which equals the derivative, I could take the 1, I could write this as, I could take the 1/2 out, so 1/2 x minus 1, and I can multiply those. Just ends up being 1/2, so I'm going to have to apply the chain rule. So that makes this a little more complicated, so please kind of watch what's going on. So we'll take the derivative of both sides. So this was just formally writing the derivative. Alright, so this is the same right here. I'm just taking the derivative, and now we do that, and we will have to apply the chain rule. So the derivative of this is going to be minus the derivative of this without the negative 6, or if I put the negative 6 in front, would be a negative 1 over the bottom squared. But since I had a negative, that makes a positive. The negative times the negative is positive. And I take the derivative of 3 is 0. And then if I take the derivative of this, all right, then I've got 3, and then the derivative of the inside of this is just 1/2. Okay, so that's 3 over 2. And then this one, that's going to be 2 times 3 times x minus 1 over 2 to the first power, and then times 1/2 again, because the derivative of this inside thing is 1/2. So those are where those red 2's come from. Same idea here. 3 times 3 is 9 times x minus 1 over 2 squared, but then I have to multiply by the derivative of, or by 1/2. That's the derivative of the inside. So that's where these red 2's come from. So this is what we have. So watch that chain rule. And this is my general term. So if I take the derivative, there's my constant stays out in front, then the n goes in front, x minus 1 over 2 to the n minus 1, but then the derivative of this is 1/2, so that's where that red 2 comes from. So that's the chain rule. And then we can just generalize it. This is the same, and then this is my notation, so it'd be 3/2 n, x minus 1 over 2, n minus 1, and this is the original interval convergence, which holds for the derivative. Okay? All right. So those are the differentiation. Hope those help.